Alright, welcome back to round 2 of Flipped Physics. This is Mr. Shafter, and this is going to be, again, for Unit 19. This is all about reflection, and today we're going to be talking about specular reflection and diffuse reflection. Alright, those are the two topics that we're going to be talking about in this video. Alright, specular reflection. When a reflecting surface has imperfections smaller than the size of the waves coming in, parallel rays will be reflected in parallel, and this is called specular reflection. Smooth surfaces such as glass, plastic, and polished metals will have specular reflection. When you look at a mirror, when you look at a polished piece of metal, when you look at a particular type of surface, you can tell that there's something special about that. A mirror reflects everything coming into it and doesn't change the size, the shape, the color. Whatever comes in goes back out again. That special luster that we see in metals, that special smooth, glassy, whatever you want to call it, you can see in metals, that particular type of reflection is what we call specular reflection. The term speculum comes from the Latin for mirror. So surprisingly enough, specular reflection means mirror-like reflection. It's what we see in mirrors. Now, in order to have specular reflection, you've got to have a smooth surface. You cannot have a rough surface. The reason for this is that if we take a smooth surface, then all of the normals are going to be parallel to one another. That means that when light comes in, regardless of where it strikes, if it's in parallel, it's going to bounce off in parallel. So the light coming in bounces out, regardless of where it hits, bounces out. Regardless of where it hit, bounces out. So when we have this light coming in, if we're the observing over here, we're going to see the light coming as though it was in a straight line from down here. It's going to go zoom up that way. And because of that, we see an image as though we're looking straight through and seeing something down here, even though the actual light is being emitted up here. And that specular finish, that mirror-like finish, that is a special case for reflection. It happens in metals. It can happen in glass. It can happen in other materials. But it has to be a smooth surface, and it has to be a particular type of material in order for that to happen. All right, that is what we call specular reflection. It's the reflection that you see in a mirror. All right, there's another type of reflection, and that is, of course, going to be, if I can find it here, that's not it, there we go, diffuse reflection. When light hits a rough surface, it is reflected in many different directions. This is called diffuse reflection or a matte finish. And the roughness of the surface depends upon the size of the wave that hits it. All right, when I hold up this piece of paper, light coming off of the lamp over my head is going to strike this and be reflected in all directions. Regardless of which direction I hold it, you're going to see light coming off of it because it evenly bounces off that light. It evenly reflects that light in all directions. It's because of the surface, and it's because not that the surface is rough in terms of us feeling it, but it's rough at the microscopic level of the light. The paper itself, even though it's smooth to the touch, and this is smooth, I mean this is as smooth as you could get a mirror when you're touching it, but the material itself, you have layer upon layer upon layer of molecular materials, and there's gaps between those molecules, and light can infiltrate between those gaps and go down 1, 2, 3, 4, many different layers, bounce off of the molecules down below and bounce off of all the subsequent molecules and then come back on out. Because there's no simple straight line path, it can go in all different directions. It can be scattered. And the scattering effect is what happens when you have a light coming into a material like this. Now, it can be a smooth surface like this paper. It can be a rougher surface like this cloth that is making up my shirt. It can be a whole variety of different types of materials. And because it can be a whole variety of different types of materials, most of what we see, most of the reflection that we see in the world is going to be what we call diffuse reflection. It's not going to be the special reflection that we call specular reflection. It's going to be this diffuse reflection, because that's the general way in which things are made up, is that they're not this smooth, shiny, metallic finish. Now, it depends upon the size of the wave whether we're going to get specular or diffuse reflection. And the best example I can give you would be a dish from a satellite dish TV receptor. If you look at these things, they're basically mirrors. They're little concave mirrors that focus the light, or not the light, the radio waves rather, up at the antenna at the far end. And we don't want light to focus up there. That would be a bad thing because we'd end up burning up the antenna. So in the visible part of the spectrum, the reflective coating on the mirror, on the dish part, is a matte finish for light. But in the radio frequencies, and remember, radio waves are really long. In the radio part of the frequency, this is a nice smooth finish. And so everything's going to be focused on the front part of the dish. It's going to be focused into that little area where the antenna actually is. And that's going to allow the radio signal to be much stronger there, and that allows us to pick up this relatively weak signal, transmit it into our amplifier in our house, and be able to watch whatever we want to on cable TV. We don't want a specular reflection in the optical part of the frequency band, but we certainly want it in the radio part, because we want it to have this nice concentrated beam right at one particular spot. Diffuse reflection, specular reflection, all aspects of reflection, and it can range from 100% specular, which is a mirror, to 0% specular, which would be something like a piece of paper or the surface of a ping pong ball. Or if you want to think of it, think of powder like flour. That's not shiny. That is about as good of a matte finish as you're going to find, because you have very small particles scattering light in all different directions. All right, that does it for specular and diffuse reflection. This is the second part of the flip video for Unit A19. I'm Mr. Shafter. If you have questions, send me an email, post them on the forum. If not, I will see you tomorrow, and we'll find out how much you learned. Talk to you later. Bye.